CoTerminal angles. These are just angles that end with the same ray. So if we have the angle 210 degrees, that means it goes all the way over here and ends right here with this ray. This angle we can also look at as pi over 6. That's as 7 pi over 6. So 7 pi over 6 all the way over here, 6 pi over 6, and another pi over 6. So this angle measure in radians is 7 pi over 6 radians, or 210 degrees. Now there are other angles that end in the same place. For example, if we were to go all the way around this circle and add another 360 degrees, we would end right back here at the same place where we had 210 degrees. Consequently, if we're looking in terms of radians, we have 7 pi over 6 radians. If we go 2 pi radians all the way around from here, we're going to end up right back in the same place, or at that same ray, that same coterminal place. So in order to find a coterminal angle, there are infinite. We can start with 210 degrees, so let's look at that. We can add 360 degrees, so that just means we go from here all the way around the circle and end back in the same place. So they often ask for a positive coterminal angle and a negative coterminal angle. So we can add 360 degrees and we get a coterminal angle of 670 degrees. If we wanted another positive coterminal angle, we could add another 360 degrees to this 670 degrees. So we could continue to get positive coterminal angles. Now, if we want to get a negative coterminal angle, we can go back the other way. So we can go clockwise back here. So we can subtract 360 degrees going in a clockwise way. So 210 degrees minus 360 equals negative 150 degrees. And so that is, if I go from here and I go negative 150 degrees, I'm going to land at that same place. I'm going to end at that same ray. So negative 150 degrees is coterminal with 210, which is also coterminal with 670. And we could even go more negative too. We could subtract another 360 degrees. Now say we looked at this in radians instead. So this is exactly the same angle, it's just in radians instead of degrees. And instead of adding 360 degrees, we add the radians. So we need 2 pi radians. So 7 pi over 6 radians plus 12 pi over 6 radians. That's the same as 2 pi. So I'm just adding on another 2 pi radians, which just gets me right back to that same ray, and that's just 19 pi over 6. So 7 pi plus 12 pi is 19 pi over 6, and that's a positive coterminal angle. And consequently, I can also subtract 2 pi radians. When I do that, I'm just subtracting, going in a clockwise way. My other ways should be like this. In a clockwise way, this way, and come back to here, and I get back to the same place. So subtracting 12 pi over 6 radians, which gives me a total of negative 5 pi over 6. And I can see that if I go negative 5 pi over 6, I end up right here. Also notice that 19 pi over 6 is the same as 670 degrees, so I could convert from radians to degrees, or vice versa. And the same is true right here. So when I'm adding 2 pi, that's equivalent or subtracting 2 pi, it's equivalent to subtracting 360 degrees. Let's look at some other examples. So if I want to find a positive and a negative coterminal angle with 600 degrees. So here I have 600 degrees, and this is the way sometimes people will tell you it's going around more than once. So here's 360 degrees, and plus enough to get you to 600. So here we have 360, and then we're adding another 40 plus another 300, and we end up right here at 600 degrees. So that just shows you that that angle goes around more than once. So 600 degrees, if we want a coterminal angle, well, if we subtract 360 degrees, we're still going to get a positive number because 600 is so much bigger than that. So we can actually go back around, we can subtract it and end up back here right at the same place. So 600 degrees minus 360 degrees gives us 240 degrees. Now if we want a negative coterminal angle, we can use this as well because it's coterminal with this. So we can just find another angle that's coterminal with 240 degrees. So I can take 240 degrees and subtract the distance around that whole circle, which is 360 degrees, and I end up with negative 120 degrees. And so that's a negative coterminal angle. Now let's look at 11 pi over 4 radians. So if we're looking at that and that angle measure, I'm going all the way around the circle one time. That's 8 pi over 4, plus another 3 pi over 4, and I end up right here. Now oftentimes when you're finding coterminal angles, especially if they're more than 360 degrees or if they're more than 2 pi, you can actually look at this and see where that's ending up. We can see that that is 1 pi over 4, 2 pi over 4, 3 pi over 4. We can see it just by looking at it. But if not, we can just subtract that 2 pi. We know it's greater. This is greater than 2 pi, so if we subtract 2 pi, we're still going to get our positive angle. And we could, if you wanted to, get a positive angle where we added 2 pi to this 11 pi over 4, and that would also be a positive coterminal angle. But if we get this, this will actually help us get our negative one. So 11 pi over 4 minus 8 pi over 4, this should be a 4 right here, and that's just the same as 2 pi. That gives me 3 pi over 4, which I can see that 3 pi over 4 is also going to end in the same place. Now a negative coterminal angle, I'm just going to take 3 pi over 4, which is also coterminal with 11 pi over 4, and I'm going to subtract 2 pi. I'm going to go around the circle in a backwards way. So when I do that, I get negative 5 pi over 4. So 3 pi over 4 minus 8 pi over 4 is negative 5 pi over 4. And I can see if I go negative 5 pi over 4, I'm going to end in that same place that 11 pi over 4 ended and 3 pi over 4 ended. So that's how you find a coterminal angle. And I could continually subtract 2 pi from these values I get and get more and more angles that end in the same place. And I could continually add 2 pi and get more and more angles, more and more coterminal angles that end in the same place.